Hello, and welcome to Kognito Key. Today, we're going to unlock a really cool concept that, believe it or not, powers so many of the apps you use every single day. It's called the domain state model, and it's the invisible logic that helps software keep track of everything from your pizza order to a major scientific discovery.
Just think about it for a second. You order a pizza on your phone, and somehow the app knows exactly what's happening. Is it being prepped? Is it in the oven? Is it on its way to your door? That's not magic, right? It's software, very carefully tracking the state of your order through its entire little journey. Well, the secret lies in tracking its state, which is just a fancy way of saying its specific status at any given moment. So your pizza moves from the being prepared state to the baking state and finally to out for delivery. And to manage that whole journey, software needs a map. And that map is what we call a domain state model.
Okay, so what exactly is a domain state model? The easiest way to think about it is like a blueprint. Yup, a blueprint. It's a detailed plan that tells a specific object in your software, like our pizza order, exactly how it should behave from the beginning of its life to the very end. So, to get a little more formal about it, this blueprint maps out three really critical things. First, all the possible states an object can be in. Second, the specific events that trigger a change from one state to another. And third, the rules it has to follow while it's in a particular state. It's kind of like the complete predictable life story of an object in your code. To make this crystal clear, let's switch gears. We'll leave the pizza behind and use a different example: the process of publishing a scientific paper. Its life cycle is super well defined, which makes it absolutely perfect for understanding how these models work. So how do you actually go about creating one of these models? It's really not as complicated as it might sound. The whole process can be broken down into 5 logical steps, and it takes us from just a basic idea all the way to a full visual map. So it all starts with finding the right objects. Then we list out all their possible states and the events that connect them. From there, we actually build a diagram, the map, and finally, we take a good look at it to make sure it's correct. Let's walk through this using our scientific paper example, shall we? Step 1 is to identify the classes that have states. See, not every little object in a system needs a state model. We only really care about the ones that have a meaningful life cycle with different phases. In our example, the main object, or class, is of course the scientific paper itself. Next up, step 2, we identify the states. A state just describes what the object is doing at a specific moment. For our paper, it starts its life in the being written state. After it's submitted, it moves to under consideration, and from there, its journey can end in one of 2 final states: accepted or rejected. Now, for step 3, identifying the events. If the states are the destinations, think of the events as the actions that actually move you between them. The paper goes from being written to under consideration because of the submission event. It moves to accepted thanks to the approval event. Simple, right? Step 4 is where it all comes together. We actually construct the state diagram. Now this is the fun part, where you draw everything out, you use boxes for the states, and then arrows for the events or transitions that connect them. It literally becomes a visual flowchart of the object's life. And finally, step 5, analyze the diagram. You have to check your map for mistakes, Does the journey have a clear start and a clear finish? Are there any states that are impossible to get to or any dead ends that you can't get out of? This final check makes sure the logic is totally solid. But here's where it gets even more interesting. Not all object life cycles are the same. Some of them are progressive. They're like a one-way street toward a final destination. But others are cyclic, meaning they repeat states over and over again. Our scientific paper is a perfect example of a progressive life cycle. It just keeps moving forward to a final outcome. Once it's accepted, it doesn't go back to being under consideration. But think about an airplane. It has a cyclic life cycle. It goes from maintenance to getting loaded, to flying, to getting unloaded, and then right back to maintenance. It's a repeating loop. So we've gone through the what and the how. But now let's talk about the big one, the why. Why do software developers even go through the trouble of creating these models in the first place? What are the practical, real-world benefits? Oh, the benefits are huge, really. First, they bring so much clarity to what could otherwise be super confusing logic. They also ensure predictability, making sure the software behaves exactly how you expect it to. This, of course, leads to fewer bugs, because you can spot flaws in the logic on the diagram itself way before any code gets written. And maybe most importantly, they improve communication,
giving the whole team a single shared picture of how everything works. So the next time you see an order tracker update, you'll know the kind of model that's working hard behind the scenes. But I want to leave you with a final thought. Just look around you. A traffic light, a load of laundry, even your morning coffee has a life cycle. What's something in your world that you could map out with states and events right now?
I really hope this explainer made the domain state model just a little bit clearer for you. If you found it useful, please give this a like and share it, and of course, be sure to subscribe to Kognito Key for more explainers just like this one. Thanks so much for watching.